Hey everyone, this is Miss Davis, and in this video we are going to talk about Module 1, Topic 1, Lesson 3, or at least the first part of that lesson. So please make sure you have either downloaded these notes from Canvas into Notability, and you can take notes along that way, or you have your textbook, or you have the packet that you got in class from the textbook. Please make sure you are following along and taking notes as you watch this video. So, Module 1, Topic 1, Lesson 3 is talking about parallel and perpendicular lines. We are going to skip the getting started. And we are actually going to skip the activity 3.1 as well. So the constructing parallel lines, that is not something that we are actually going to do in geometry this year. So we're going to skip how to construct parallel lines. So that was on page 36. We're going to skip page 37 as well. On page 38, it's teaching you how to duplicate an angle, which we actually did that construction yesterday. So we went ahead and taught you how to copy an angle, how to duplicate an angle when we did the other constructions from lesson 2. So we've already done this, so we can skip over that as well. So where we're actually going to start is going to be on page M139, and we're going to look at number 6. So number 6 on page 39 says, consider the line y equals x on the coordinate plane shown. A wants us to translate the line y equals x to create a parallel line. Remember, parallel means that it will never cross. So what I'm going to do, since I'm using Notability, I'm just going to copy this line, I'm going to trace over it, and then I'm going to take it and I'm going to move it. I can move it wherever I want. All of these, anywhere I put it is going to be parallel to that original line. So I'm going to put mine right there. Part B says to write the equation of your line. So think back to Algebra 1 last year. When you write equations of lines, most of the time we write them in slope-intercept form. So that's going to be y equals mx plus b. So if we look at our line, remember b is the y-intercept, so that's where it crosses the x-axis. So our line that we just did right here crosses the x-axis at 3. So our y-intercept is 3, and then m stands for slope. So m is the slope. We can find that by doing rise over run. So we go up 1 over 1 till we get to another point. So that means our slope is 1. So the equation of this line is y equals 1x plus 3. You could also write that as y equals x plus 3, same thing. So we know that this line that we just created, y equals x plus 3, is parallel to y equals x because we translated it to create that line. So we know that it will never cross. They will never cross each other. Part C wants us to describe the slopes of parallel lines on the coordinate plane. Well, if we look at our equations, so the original line that we were given, it would have a slope of 1. So remember, the slope is the number in front of x when it's written in slope-intercept form. So y equals x, that's like saying y equals 1x. So we know this line has a slope of 1. And our translated line also has a slope of 1. So we can describe the slopes of parallel lines as being congruent. So parallel lines have the same slope. You probably learned that last year in Algebra 1. Hopefully that's a review, but if not, that's okay. Just know that parallel lines have the same slope. All right, let's move on to the next page. So now we're on page 40, and we're going to look at activity 3.2. So slopes of perpendicular lines. So it says, recall that perpendicular lines or line segments form a right angle at the point of intersection. Consider the 3 graphs shown. Each shows a line and its rotation 90 degrees about a point, which is also the point of intersection. Number 1 asks, are Are the lines in each graph perpendicular? Explain your reasoning. Well, if we go back to what it told us, it says that each shows a line and its rotation 90 degrees, about a point. That is also the point of intersection. So if we take one of our lines and rotate it 90 degrees, doesn't that mean that those two lines would have to be perpendicular? Yes. So we know that they're perpendicular because it tells us that the lines are rotated 90 degrees. There are also other ways we can figure out that these lines are perpendicular to each other. So since we know that they are perpendicular because they are rotated 90 degrees, we can go ahead and put boxes in here for these if you would like. You don't necessarily have to, but you can. And then we are going to talk about other ways we can figure out that those are perpendicular. So in number 2, it wants us to write the equation for each line and its transformation. What do you notice? So I want you to go back and look at these 3 graphs. So if you look at this very first graph, I want you to look at the blue line and the pink line. I want you to write the equation of both of those lines and see what you notice about those equations. Then do the same thing for the second graph. Write the equation of the pink line, write the equation of the blue line, and then see what you notice. Same thing for the third graph. So you're going to be writing the equation of 6 different lines, and then you're going to look and see what you notice. So go ahead and take a minute, pause the video, and answer these questions, and then when you have finished, play the video to see if you are correct. All right, so when you did this, so for this very first one, when we do the pink line, that pink line should have had an equation of y equals negative x. So the y-intercept is 0. It crosses the y-axis at 0. And to get the slope, we went down 1 to the right 1. So down 1 to the right 1 would be negative 1 over 1, which is just 1. So y equals negative x. If you have y equals negative x plus 0, that's fine. Or if you have y equals negative 1x plus 0, again, same thing, that's fine. For the blue line, you should have gotten the equation y equals x. So again, the y-intercept is the origin is at 0, and then we went up 1 over 1 to get to the next point. So the slope would be 1 over 1, which is just 1. Again, same thing, if you have y equals 1x, or y equals 1x plus 0, or y equals x plus 0, that's all the same thing, that's all fine. So hopefully with this graph, you noticed that the y-intercepts were the same, and I hope you noticed something about the slopes. I'm not going to say it just yet because I want to look at the other ones and then we'll talk about the slopes, but hopefully you did notice something about the slopes of these lines. Let's look at the second graph. So this pink line, hopefully you got that the equation was y equals negative 3x plus 5. And of the blue line, hopefully you got that the equation is y equals 1/3 x plus 5. Again, when you are trying to notice something about these, hopefully you noticed that the y-intercepts were the same, and hopefully you noticed something about their slopes. Let's look at the last graph. So when you wrote the equation of this pink line, you should have gotten y equals negative 2/3 x plus 9. And the equation of this blue line is y equals 3 over 2x minus 4. When you're noticing things about this graph, hopefully you notice that our y-intercepts for this one are not the same. So these other two graphs both had the same y-intercepts, but this graph does not have the same y-intercepts. So what that is telling us is that the y-intercepts have nothing to do with our graphs being perpendicular. They can be the same, they don't have to be, but that has nothing to do with our graphs being perpendicular. Hopefully, when you look at the slopes, you can figure out what has to happen to make these have perpendicular lines. So if you look at this one, so our slope was negative 2/3 for this pink line and 3 over 2 for this blue line. Hopefully you noticed those are opposite reciprocal slopes. Opposite reciprocals. So opposite meaning one slope is positive, the other is negative, and reciprocal, remember, is when you take your fraction and flip it upside down. So hopefully you can see that those are opposite reciprocal slopes. Let's check the other graphs. So if we look at this graph, the pink line had a slope of -3, whereas the blue line had a slope of 1/3. Those are also opposite reciprocal slopes. So one's positive, one's negative, and then we take our fraction and flip it upside down. So we take -3, make it positive, and technically we can write 3 as 3/1, flip that fraction upside down, and it becomes 1/3. Let's look back at the first graph. So the slope of the pink line was -1, and the slope of the blue line was 1. So hopefully, again, you can see that they're opposite. One's positive, one's negative, and they are reciprocals of themselves because -1/1, or just 1/1, the reciprocal of that would still just be 1/1. So those are also opposite reciprocal slopes. So what I really needed you to get out of this is that perpendicular lines have slopes that are opposite reciprocals. So slopes are opposite reciprocals. Perpendicular lines have opposite reciprocal slopes. If we look at this next page, let's look at this blue box over to the side. So it says the product of the slopes of perpendicular lines is -1. That is just another way to say that the perpendicular lines have opposite reciprocal slopes. Because if we think about it, so if we think about that last graph, one of our slopes was 3/2, and our other slope was -2/3. So if we just use that as an example, so the product of the slope of perpendicular lines, so product means the answer to a multiplication problem. So when I multiply these two slopes together, it should give us -1. And it does, because if we multiply fractions, remember we just multiply straight across, so we can do 3 times -2 and get -6 over 2 times 3, which is 6, and that simplifies to -1. So if you would like to think of perpendicular slopes having a product of -1 instead of they're opposite reciprocals of each other, that's fine. It's really the same thing. I will always call it opposite reciprocal slopes, but you're not wrong if you say that their products is -1. This worked example goes through and explains why that works out, but it can kind of get a little confusing, and I don't really want to confuse you with all this. So I would rather you just know that perpendicular lines have opposite reciprocal slopes instead of trying to go through this worked example. So we're going to kind of skip over that. We're also going to skip number 3 on that next page, but I do want to look at number 4. So number 4 says line J and line K are perpendicular. Given each slope of line J, determine the slope of line K. So for A, if the slope of line J is 2/3, we want to write the perpendicular slope for line K, which is going to be the opposite reciprocal. So 2/3 is positive, so our slope is going to be negative, and we're going to take our fraction and flip it upside down. So we're going to have -3/2 as our perpendicular slope. For B, we have a slope of -4/5. The opposite reciprocal slope, the perpendicular slope for that one, would be a positive 5/4. And for C, we have the slope is -3. Remember, we can think of that as -3/1. So the perpendicular slope for that one would be a positive 1/3. All right, let's keep on going. So now we're on page 43. We're going to talk about horizontal and vertical lines. So we're going to consider this graph shown. Number 1 tells us to use a straight edge to extend line segment JK to create line P. So I'm going to do that. If you are doing the notes on paper or in your textbook, you will need to use a ruler or a straight edge to do this. but if you're using Notability, you can just make sure you use straight lines. So we're going to extend line segment GK to create line P. So, oops. So I'm going to extend it. It's going to look like this. It's going to become a line, so I need to put arrows on the end. And I'm going to call this line P. We are also going to extend line segment GH to create line Q. So I'm going to extend this, again, using my straight edge if you're taking notes in the actual textbook or on the note packet. And then I'm going to call this line Q. We need to extend line segment FJ to create line R. And finally, we are going to extend line segment KL to create line S. All right, let's look at number 2. Number 2 says, consider the 3 horizontal lines you drew for question 1. For any horizontal line, if x increases by 1 unit, by how many units does y change? So let's think about this one. So our 3 horizontal lines would be lines Q, R, and S. And it asks for any horizontal line if x increases by 1 unit. So let's just look at line Q. So if I just pick a point on line Q, so let's say this point here. If we increase x by 1 unit, so if I move x over 1, how many units does y change? Well, it doesn't, because it's still on a horizontal line. So if we increase x by 1, y stays the same. So our answer to this is it doesn't. It changes by 0. Number 3 asks us to describe the slope of any horizontal line and explain your reasoning. So remember, if we have a graph, we can find slope by doing rise over run. So if we think of 2 points on any of these horizontal lines, so let's just use the 2 points that we end up having here that we looked at for point number 2. So we want to do rise over run. How many do we rise? 0. How many do we run? 1. So we end up with like 0 over 1, or we had 0 over any number, really, because we could have used a point over here, and then that would have been, we rose 0, we ran 3. So we would have 0 over a number, which is just 0. So the slope of any horizontal line is just 0. The reason for that is, as x increases, y stays the same. So as x increases, y stays the same. I'm also going to write out over here where we had 0 over a number. So we rose 0, we ran however many we wanted to run, and we got our slope of 0. All right, let's look at number 4. Consider the vertical line you drew in question 1. So now we're looking at line P, the vertical line, the one that's straight up and down. Suppose that y increases by 1 unit. By how many units does x change? So if we look at a point on line P, so let's just pick this one. And let's say we change the y value by 1. We increase the y value by 1. So this point has a y value of 1, right? Because it's the point 4, 1. So if we increase the y value by 1, it would become this point here, which would be 4, 2. Did x change? Hopefully you can see that x did not change. So if we increase the y value by 1, x stays the same, which means we're going to put that it doesn't change, it increases by 0. All right, describe the slope of any vertical line. Explain your reasoning. So again, remember, slope we can think of as rise over run. So if we just use those 2 points that we looked at, we rose 1 and we ran 0. Or if we pick a different point, so we could look at like these points. We rose 2 and we ran 0. So we have a number over 0. Can you divide by 0? Hopefully you remembered that you cannot divide a number by 0. If you were to put it in your calculator, like 1 divided by 0 or 5 divided by 0, it would give you an error, which means the slope of any vertical line is undefined. So vertical lines have undefined slope. And the reason for that is as y increases, x stays the same. So as y increases, x stays the same. And again, I'm going to write out what we kind of already talked about. So we have a number because we rose however many we needed to on that line. And then we ran 0, and that gives us an undefined slope. To help you remember where 0 can be, so if 0 can be on top or on bottom, I have a little trick that you can kind of remember. So 0 on top is okay. So we have 0 over a number, it's okay, it's just 0. However, if we have 0 on bottom, that's no way. So 0 on top is okay, gives us just gives us 0, and 0 on bottom is no way. So we have NO, so that means it's undefined. So anything divided by 0 is undefined. So if that helps you, then you can use that. All right, we're going to look at one more page in this video, so page 44. Number 6 says, determine whether each of the given statements is always true, sometimes true, or never true. Explain your reasoning. So let's look at A. A says all vertical lines are parallel. So let's think about this. Vertical lines, remember those are the ones that are straight up and down. So if we think about two vertical lines, those would both have a slope of undefined, right? Isn't that what we just came up with? Because if we'd do rise over run, but we wouldn't run any, so we'd have a number divided by 0, which would just give us an undefined slope. Remember, parallel lines have the same slope. So these do have the same slope. They are both undefined slope. So this would be always true. So all vertical lines are parallel always. And our reason behind that would be because they have the same slope. What about all horizontal lines are parallel? So if we have horizontal lines, those are the ones that are side to side, so like this. We know horizontal lines have a slope of 0. Again, we talked about that on the last page. Again, these have the same slope. They both have a slope of 0. That means that they will be parallel. So this one is also always true because they have the same slope. All right, number 7 says, describe the relationship between any vertical line and any horizontal line. So if we think about a vertical line and a horizontal line, hopefully you know that the relationship between those is that they are perpendicular. We can think about this in terms of the slopes. So the vertical line is going to have a slope of undefined. Remember, we can also think of that as a number divided by 0. Whereas the horizontal line is going to have a slope of 0, which again, we can think of as 0 divided by a number. Do you see how those could be opposite reciprocals of each other, depending on which number we chose? So hopefully you can see that those will always be, a vertical line and a horizontal line will always be perpendicular to each other because they have opposite reciprocal slopes. All right, let's look at number 8. Number 8 says write an equation for a horizontal line and an equation for a vertical line that pass through the point 2, -1. So before we do this, I want to go back and look at the graph that we had at the beginning of the activity 3.3 so that we can talk about how to write the equations of these lines. So let's look at our horizontal lines first. So let's look at line Q. So if we just pick random points on line Q, so let's pick this one. This is the point 1, 4. Let's pick this one. This point is the point 4, 4. Let's pick this one. So that would be the point 11, 4. And let's do one more. Let's pick this one here. So that would give us the point 15, 4. What do you notice about all those points? What do all those points have in common? Hopefully you can see that they all have a y value of 4. So that means the equation of this line, this horizontal line, is y equals 4. That's going to be the case for all horizontal lines. All horizontal lines are going to be y equals a number. So if we look at line R, again, we can pick points on line R. So if we pick this point, that is the point 1, 8. We pick another point, let's do this one. That would be the point 4, 8. And let's do one more, let's pick this one. So that would be the point 11, 8. Again, hopefully you can see the y values are all the same. So this is going to be the equation y equals 8. So going with that, hopefully you can see that line S would be the equation y equals 12. So any horizontal line is going to be y equals a number. Now let's look at our vertical line, so line P. Let's pick some points on line P. We actually already have a few. So we know this point here we said was 4, 4. We have this point here, which we said was 4, 8. Let's go ahead and just do this point here, which is the point 4, 12. And let's do one more. Let's do this one, which is the point 4, 15. Hopefully you notice with this one, with this vertical line, that all of the x values are the same. So all of these have an x values of a value of 4. So that means the equation of this vertical line is x equals 4. So vertical lines will have the equation x equals a number, whereas horizontal lines will have the equation y equals a number. You do need to memorize that. You do need to be able to tell me that if it's a horizontal line, it's y equals something. If it's a vertical line, it's x equals something. So please make sure you understand that. Please make sure you study that. So let's head back over to number 8 on this next page. So it told us to write an equation for a horizontal line and an equation for a vertical line that pass through the point 2, -1. So let's start with our horizontal line. So horizontal lines, we just said that that's y equals a number. So we know it's going to be y equals. We also were given a point that we know that it goes through. So we know it has to go through 2, -1. So that point has to be on our horizontal line, which means it has to go through the y value, which would be -1. So the equation of a horizontal line that goes through the point 2, -1 would just be y equals -1. And if we look at a vertical line that goes through that point, remember we just said that vertical lines are x equals a number. So we have x equals, and we know it goes through this point, so we can use x equals the x-coordinate of our point, which is 2. X equals 2. Please don't make these more difficult than they have to be. You just really have to kind of think about these problems. So try not to overcomplicate questions like number 8. Let's look at number 9. Number 9 says write an equation for a line that is perpendicular to the line given by x equals 5 and passes through the point 1, 0. So we want an equation for a line that is perpendicular to the line given by x equals 5. So if we think about the line x equals 5, since it's x equals a number, we know that that has to be a vertical line. So that is a line that's straight up and down. Well, what's perpendicular? What type of line is perpendicular to a vertical line? Hopefully saying that that is a horizontal line. So the line that we want is going to be horizontal. So we know the equation of our line has to be y equals a number because we want a horizontal line, which has y equals, and we know it goes through this point, so we know that y is going to be equal to the y coordinate of our point, which is 0. So our answer for this one would be y equals 0. And the last one we're going to look at for today is number 10. Number 10 says write an equation for a line that is perpendicular to the line given by y equals -2 and passes through the point 5, 6. So we want it to be perpendicular to y equals -2. Y equals -2. We know if it's y equals a number, it's horizontal. So we know this line is horizontal. Well, what type of line is perpendicular to our horizontal line? A vertical line. So we know we are looking for a vertical line, which means the equation is going to have to be x equals a number, because vertical lines all have the equation x equals a number. And then we know that it's going to pass through the point 5, 6, so the x coordinate of that point would be 5. So we can say x equals 5. That is our answer to that problem. All right, I hope you were able to understand all of that. I hope you got all of these notes taken down. A lot of this should have been a review from Algebra 1, but if it's not, that's okay. Hopefully you learned something from this video. Your assignment for today is going to be a derivative. It is on slope. So that your derivative that you can find on Canvas, it's called slope practice derivative. It does require work, and guys, it is on slope. It's supposed to be really easy, or should be really easy. So you will need to find slope from a graph, from 2 points, from an equation, that type thing. So I do want to kind of remind you about slope. Again, this is a review from Algebra 1, but just in case you forgot. So when you are finding slope, if you're given a graph, so if you're given a line on a coordinate plane, you can do rise over run. You can also use the slope formula to find slope. So that can be whether you're given a graph or if you're just given 2 points. So if you are using the slope formula is m equals y2 minus y1 over x2 minus x1. So you would pick 2 points, or hopefully it might even give you 2 points, and you can label those your x1, y1, and x2, y2, and just plug into the slope formula. Again, hopefully you saw that in Algebra 1. You definitely should have. And then the last way we can write slope or find slope is from an equation. So most of the time, we are going to use slope from slope-intercept form, which is y equals mx plus b. So remember, the slope is going to be the number in front of x when it's in this form. But be careful, you may not be given an equation in slope-intercept form. So you may have to first get y by itself before you can just look for the number in front of x. So be careful with that. So there are, I think, about 11 questions talking about slope, just slope, guys. This is really just a review from Algebra 1. And you do have to submit a picture of your work. The ones that definitely, absolutely, positively should have work are the ones where you have to find the slope using 2 points. So you're going to use the slope formula for that. So some of the other ones you can do without showing work, but those, when you're given 2 points and have to find the slope, I absolutely should see work for that. So you can do that in Notability, or you can do that on paper and then just submit a picture of it for number 12. Alrighty, if you have any questions, please feel free to send me an email. Your slope worksheet or slope derivative is due the next time I see you, Monday morning or afternoon if you're in third block. So I hope you guys have a great weekend. Enjoy your hopefully a lot of snow day, and I will see you guys on Monday.